Hi everyone. In the last video, we went through concepts on cost, revenue, marginal cost and marginal revenue. In this video, we'll go through few more problems related to them. Let's take this problem. The total cost of production of a firm is given by following function. Cost function is given. Find the total cost for an output of 10 units. Total cost is given. You have to find the cost when the output is 10 unit. What is output? Output is number of units. X, they've told X is equal to output. So instead of X, we'll have to put 10. So first one, total cost when output is equal to 10. Nothing but when X is equal to 10. This is nothing but total cost is equal to 0.7 into 10 plus 18. I'm taking this cost function here. Nothing but 25. 25 rupees. Let's not forget this unit, 25 rupees. Second one, we have to find average cost when output is equal to 9. That is X is equal to 9. So average cost is equal to total cost by quantity. Quantity is output or X, right? Total cost is 0.7 X plus 18 by quantity is X and X is 9. So 0.7 into 9 plus 18 by 9. So when you calculate this, you're going to get 2.7 rupees. Now similarly, we can take third one, the marginal cost. Now what is marginal cost? Derivative of total cost. When you differentiate total cost, you'll get marginal cost. Total cost is 0.7x plus 18. 0.7x plus 18. I need to differentiate this. So I'll get 0.7. So marginal cost is 0.7 rupees. That's all. So here's the sixth problem. If R, that is if revenue is given by this particular function, what will be the marginal revenue if X is equal to 25 units and average revenue if X is equal to 10 units. So there are two problems here. We'll have to find the marginal revenue when X is equal to 25 and average revenue when X is equal to 10. Right? We have the revenue function. We know the formula for average revenue and marginal revenue. So we know revenue is 250x plus 45x square minus x cube. So marginal revenue is equal to derivative of total revenue. Remember this, the denominator should always be quantity or units or output or quantity. So here X is the units, X is the number of units, so it should be X. So differentiate this. Derivative of 250x is 250. Derivative of 45x square is 90x minus 3x square. Now you need to find marginal revenue when X is equal to 25. So straightforward, just substitute X here, right? Let's substitute X. So we'll get 250 plus 90 into 25 minus 3 into 25 the whole square. If I calculate, I will get marginal revenue as 625 rupees. Exactly in the same way, we'll have to find average revenue when X is equal to 10 units. Formula for average revenue is total revenue by quantity. Total revenue function is given. Quantity is X. You can split each of this, right? So that X and X will get cancelled and you'll get this average revenue. And then you substitute X is equal to 10 because we have to find average revenue when X is equal to 10. And you'll get average revenue as 600 rupees. So let's look at the seventh problem. The total cost function of a manufacturer is this one, this function. Find the output when AC is equal to MC. When average cost is equal to marginal cost, we'll have to find the output. Output is the number of units, quantity. Now, total cost function is given. We need to find output when AC is MC. So find average cost. First find average cost. Then find marginal cost. Equate them. And when you equate, you will surely get the value of X. Right? So average cost is total cost by quantity. Total cost is given here. Quantity is X. Right? And marginal cost is differentiation of total cost. You differentiate this function. You will get 10x plus 500. Equate both of this. Output when AC is equal to MC. AC is equal to MC. Equate this one and this one. You equate because AC is equal to MC. So when you equate, you will get a expression like this. Now from this, you will find out X value. right? That X is nothing but the output level, right? This X is what? You get output level, which is 100 units. When X is 100 units, or when the number of products sold is 100 units, you will see that average cost is same as marginal cost. Let's take the 8th problem. If R, or if revenue is given by this function, what is the marginal revenue function? What is the marginal revenue function? And what will be the marginal revenue if 100 units were produced? That is, if X is equal to 100, what would be the marginal revenue? So, simple. Revenue is given. Marginal revenue is differentiation of total revenue. You differentiate. Always remember, differentiate with respect to quantity. X is the quantity. So, you find the derivative. You will get 15 minus X by 15. Now, we will have to find marginal revenue when X is equal to 100 units. So, instead of X, you put 100. You will get 8.33. So, marginal revenue is 8.33 when X is equal to 100. Simple. And this is the marginal revenue function. Right? This is marginal revenue function. This one. Let's go to 9th problem. The total revenue and the total cost function of a company are given by revenue is given, cost is given, Q is the output or Q is the units, right? Find the equilibrium output. Equilibrium. Equilibrium means marginal revenue is equal to marginal cost. That's when we say it's equilibrium. That is, inflow and outflow should be same. When inflow and outflow is same, that's when we can say it's at equilibrium, or it's in the profit maximization state. It's in profit maximization state. Total revenue is given. We need to find marginal revenue. We need to find marginal cost. Equate them. Marginal revenue is differentiation of total revenue. So when you find the derivative, you get 4. And marginal cost, you have the total cost function. Total cost function is given here, right? So you find the derivative of total cost, you'll get marginal cost. Derivative of total cost is 4. And derivative of marginal revenue is 300 minus 2q. So now we'll find the marginal revenue. Marginal revenue is, you differentiate total revenue. You will get this marginal revenue function. Then you have total cost function given here. Right? This is total cost function. Right? Now you differentiate this. You'll get marginal cost. Right? When you differentiate, you'll get 4. Equate both of this. Right? Equate marginal revenue and marginal cost. 300 minus 2q is equal to 4. And then you'll get the value of q. Q is 148. What is q? Output. When the number of units produced is 148, that's when you will see an equilibrium state, or that's when you will see marginal revenue being same as marginal cost. Let's take this 10th problem. Let the demand function of an article be P is equal to 75 minus 2x. So demand function, remember, demand function means it's a relationship between price and quantity. Price and quantity, relationship between them. So P is price here and X is quantity, right? So now demand function is P is equal to 75 minus 2x. Cost function is given. Cost function is 350 plus 12x plus x square by 4. Find the number of units. That means I have to find x. And the price. That means I have to find P. And we have to find the units and price when total profit is maximum. What is total profit? Total profit is total revenue minus total cost. Inflow. This is inflow. This is outflow of money. Difference between them is the profit. Now we'll try to find total revenue. Total revenue is price into quantity. Right? Total revenue is price into quantity. So what is price? Price we can write it as 75 minus 2x. Right? Price is 75 minus 2x into quantity. Quantity is x. So what is this? 75x minus 2x square. Now we'll find total cost. What is total cost? Total cost is already given here. This one is total cost. Now what do we have to do? We'll have to subtract. We'll have to subtract this one and this one. So total profit is equal to TR minus TC. Total revenue is 75x minus 2x square minus total cost is 350 plus 12x plus x square by 4. So this is nothing but 75x minus 2x square minus 350 minus 12x minus x square by 4. So on simplifying this, 63x 9x square by 4 minus 350. So this is total profit. We'll have to find number of units and price when the total profit is maximum. I told you, right? Whenever you see the word minimum, maximum, differentiate. Whenever you find minimum and maximum in the problem, differentiate. What should you differentiate? Total profit. Because what should be maximum? Profit. So differentiate profit. You can call this as profit function. Profit function. Now you differentiate total profit. So you'll get differentiation of this entire expression, right? 63x minus 9x square by 4 minus 350. And what should you do? Equate it to 0. Equate it to 0. Don't forget this. I'll get 63 minus 18x by 4 minus 0, which is equal to 0. So this is nothing but 18x by 4 is equal to minus 63, and x is equal to minus 63 into 4 by 18. It is minus here, just left out minus. So it's going to be minus x is equal to minus 14 or x is equal to 14, right? X is equal to 14. X is units, total units when the profit is maximum, when profit is maximum is 14. Now we'll have to find price also, right? We'll have to also find price. Price, this is what is given. This is price function. P is equal to 75 minus 2x. P is equal to 75 minus 2x. Substitute. This is nothing but x, right? So substitute here. So you'll get price. 75 minus 2 into 14, which is 47 rupees. So profit is maximum. Profit is maximum when total units is 14 and when price is 47 rupees. Now let's take this another problem. A manufacturer gives the total cost. This is a cost function and this is the demand function, right? Demand function, that is relationship between units and price. This is the demand function, right? This is demand. Find the level of output at which profit is maximized. Level of output. What is level of output? Units. Quantity. And what is that? Quantity is Q. You have to find Q because output is Q is output, right? Output. So we'll have to find Q, that is output, when profit is maximized. At that point, we need to find output or number of units. What is the formula for profit maximization? Marginal revenue is equal to marginal cost. This is when the profit is going to be maximized, right? So we'll have to find marginal revenue, which is nothing but differentiation with respect to Q, because Q is the number of units. We need to differentiate total revenue, right? But we don't know what total revenue is, right? Total revenue is nothing but price into quantity. So this is demand function. Price would be 100 minus Q. When I shift P this side and Q this side, you get price as 100 minus Q. Let's substitute price here. 100 minus Q into quantity is Q. Now, you might be having a question. Instead of substituting price, we can also do this, right? We can also do this. Price is P. Quantity is already given here. Q is equal to 100 minus P. We can do this way also, right? Here we substituted price in terms of quantity. What we can do is we can leave price as P and substitute quantity like this. Both are same, but we still want it in terms of Q, because ultimately we have to find level of output, that is we have to find quantity. So it's better that we express the entire function in terms of quantity. Total revenue is, we'll take this equation, 100Q minus Q square. Now we'll find the marginal revenue. Total revenue is 100Q minus Q square. So this is nothing but 100 minus 2Q. This is marginal revenue. Now we'll have to find marginal cost, right? We'll have to find marginal cost. How do we find marginal cost? Marginal cost is differentiation of total cost. Do we have cost function? Yes, this is the cost function. So let's differentiate the cost function. So if I differentiate this, I'll get 3Q square by 3 minus 7 into 2Q plus 111. So I'll get Q square minus 14Q plus 111. So this is marginal cost function. Now for profit maximization, rule is marginal revenue should be equal to marginal cost. Here's the marginal revenue that we found earlier. 100 minus 2Q is equal to marginal cost. Marginal cost is this one. Q square minus 14Q plus 111. So when I shift, I'll get Q square minus 14Q plus 11 minus 100 plus 2Q is equal to 0. So it's nothing but Q square minus 12Q. This should be 111. So I'll get plus 11 is equal to 0. So if I factorize this, I'll get Q. Numbers would be numbers. If I factorize, I can write 11 into 1 is 11. 11 plus 1 is 12. So I need to get minus 12, right? I need to get minus 12. So I'll have to put both as minus. Minus 11 into minus 1 is plus 11. Minus 11 minus 1 is minus 12. So numbers are minus 11 and minus 1. So it's going to be Q minus 11, Q minus 1. We need to split this 12Q basically. 12Q needs to be splitted as 11Q minus 11Q minus Q. That's when you will get 12Q. That's all. So when I split and take common factor, I'll get Q minus 11, Q minus 1 is equal to 0, which means Q is equal to 11 or Q is equal to 1. Now it can be only one of them. Here profit can be maximum when either Q is 11 or Q is equal to 1. Now how do we figure out which is the right one? So what we have to do is we'll have to double differentiate because it has to be maximum. Now for maximization, we'll have to double differentiate, right? Remember, whenever you need to check, verify if it is maximum or minimum, you'll have to double differentiate. We'll have to double differentiate profit here, right? But we don't have profit directly. We have this. We have MR is equal to MC. For maximization, when you double differentiate MR and double differentiate marginal cost, right? You have to double differentiate and second order derivative of marginal revenue should be less than second order derivative of marginal cost. Remember, whenever we have to verify whether it's maximum or minimum, you'll have to double differentiate. We have the first order derivative of marginal revenue, right? Why are we using this MR less than MC? Because for maximization, it should be less than. Double the second order derivative of marginal revenue should be less than second order derivative of marginal cost. This is the derivative of marginal revenue. First order derivative, right? This is first order. Now we'll differentiate this again and get the second order. So it's going to be d of dx of 100 minus 2q. This is second order. We're trying to get the second order less than d by dx of first order derivative of marginal cost. This is first order, correct? This is first order derivative. Q square minus 14q plus 111. Now when I differentiate this, I'll get minus 2. This should be less than 2q minus 14, right? Now what will we do? What we'll do is we'll first take two values of q. At q is equal to 1 and we'll figure out at q is equal to 11 because we got two values of q here. At q is equal to 1, we'll substitute minus 2 less than 2 into 1 minus 14, which is minus 2 less than 2 minus 14 is minus 12. Is minus 2 less than minus 12? No. No, this is wrong. Not true. So q is equal to 1 is wrong. This is wrong. Now we'll take at q is equal to 11. At q is equal to 11, minus 2 less than, instead of q, we'll put 11. minus 14. So 22 minus 14 is 8. And here we have minus 2. Is minus 2 less than 8? Yes, this is true. At Q is equal to 11, profit is maximum. Okay, so answer is 11. Now remember one thing. There is a minor difference between previous problem and this problem. In the previous problem, it was total profit. So that's why we used total profit formula, which is total revenue minus total cost. Okay, and in this problem it is profit maximization. That's why we'll use this formula, which is marginal revenue is equal to marginal cost. So with this, we have come to the end of this particular topic. If you have liked this video, do press a like and share it. Thank you.